Hello friends, welcome to our YouTube channel Demo Rides. In this video, we are going to simply understand about series circuit from the theoretical aspect. So let's learn together. So at first we can see that here we have some resistance R1, R2 and R3 and we want to connect this R1, R2 and R3 in series. So what I will do, simply here we can see that here R1 we have some end and R2 we have a end. So I'm going to simply connect this R1 and R2 to a common point. Okay, I'm simply connecting this end with each other, and here R2 and R3 I'm going to simply connect R1 and R2 together at this end. So we can see that here at this common point R1 and R2 is connected, here another common point R2 and R3 is connected. Okay, so here we can see between A and B we can say that R1, R2 and R3, all of three are connected in series. Okay, here at this common point only two different resistance are connected. There is no third element is there. This is very important point because this going to allow some unique property of series connection. Okay, so here we can say that between A and B all three resistance are connected in series. Okay, now what if I connect a voltage source across this series connection? Okay, you can see this, I am applying a voltage source and this R1, R2 and R3. Now in series connection, as I told you that at this point here is only two element is connected because of some reason. Because in series connection each and every element will face same amount of current. Means here I amount of current will flow through R1, R2, R3 and this voltage source. What if we connect another single element over there? So current will simply get divided into two parts. If I connect simply a resistor over here, and there is a chance that current will get divided into two parts. But in series connection we want same current flow through the each and every element. So that's why we are not going to connect another resistor or another element at this common point. Okay, so here a same amount of I current will flow through R1, R2 and R3. Okay, now as current I is flowing through this R1, R2 and R3, so the voltage across R1 will be simply IR1, voltage across this R2 will be IR2, voltage across this R3 will be IR3. And if we add this V1, V2 and V3, we will get V equal to V1 plus V2 plus V3, means that input voltage is equal to nothing but the voltage drop across R1, R2 and R3. If we add them, then we will get the input voltage. So here we can see that each and every resistance will drop some voltage across it according to their resistance value. If the resistance value is more, it will drop more voltage, because here we can see that I value is same for every resistor, but R value for the series connection is R3 value or R value is more, then it will drop more voltage. Okay, now we have to find out the equivalent resistance between these 2 points. Okay, now the concept of equivalent resistance is that what if we could replace this whole series arrangement with a single value resistor. Okay, but and if we apply the same voltage V, and it will take the same amount of current I. Okay, and we have to find out that value. Okay, so here simply concentrate. I have simply replaced the whole arrangement and with the single value resistance R, and I am simply applying the V, and here I amount of current, same I amount of current will flow through this circuit. Okay, so at this time the voltage across this R will be what? I into R. Now this I into R equal to nothing but the V1 plus V2 plus V3, that is nothing but I R1, I R2, I R3. So from the both side we can see that I get cancel out, so we get equivalent resistance R equal to R1 plus R2 plus R3. Okay, so it was only the three resistance are connected in series. What if we connect n numbers of resistance? This equation will simply extend to R equal to R1 plus R2 dot 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 Rn. So throughout the video what we have learned that if we connected a resistance in series, so at this series connection same amount of current will flow through each and every element connected in series, that is R1, R2, R3 and this voltage source, and this R1, R2, R3 will drop some voltage across them, here V1, V2 and V3. If we add all these voltage drop with each other, that is V1, V2 and V3, if we add them we will get our input voltage back. Okay, and again if we want to find out the equivalent resistance between this point and this point, we have have to add simply all the individual resistance connected between in this point in series connection. Okay, so watch it here. So here we have the R equal to R1 plus R2 plus R3. All the individual values of each resistance are if we adding them, we will get back the equivalent resistance. That's all for this video. Thanks for watching.